Okay, in this video we are going to go over how to rationalize radicals. This is something that you learn briefly in your Algebra 1 career, but spend more time of it in Algebra 2. Since you also need to know this for the I step, it will not hurt to go through a couple processing problems. So to rationalize radicals, what we're going to do is try to find the largest multiples in which we can use to break it down. Let's do a couple examples. One would be something like square root 24. We know when we put this into our calculator, it is going to give us a decimal. But if I ask for the exact amount, then it means leave it in radical form. To do this is quite simple. You have to look within the problem's multiples. So when I go into the problem, I think of different ways that will multiply and make 24, but yet have a perfect square root as one of the factors. So for an example, 24 I know is built up of 8 and 3, but I can't square root either one of those and get a perfect outcome. Also, I can do 4 and 6. Now, 4 and 6 do have a perfect. The square root of 4 is 2. So I know that when I do this, I have square root 6. So both of these are square rooted. So when I get done, the square root of 4 is 2. 6 does not have a perfect square root, so it remains under the radical. So the answer is 2 square root 6. All right, so that was a little confusing maybe, so let's try another one. Square root 32. Now the square root of 32, once again, if you put it into your calculator, is going to be a decimal. But once again, if we're wanting to have this as a perfect answer or a exact answer, we're looking for the multiples within that have the perfect square root. Well, 32 we know is divisible by 2. So when I break it down by 2, I get 2 and 16. Right away, we get one of the possibilities. We know that the square root of 16 is going to be 4. So what I can do is I can actually stop here because we're looking for the biggest possible square rootable answer within the factors. So when I do this, I know that I can do the square root of 16, which is 4. The 2 remains underneath the radical because it cannot be broken down into a perfect square root. So here, I want you to try a couple of these, and then I will pause and let you take a moment to finish them out. So square root 72, square root 68. Make sure you pause the video here. Okay, so let's go into this. The square root of 72 is one of those that takes a little bit of breakdown. But if you think about what it's made up of, it makes it a lot easier. Most people think of right away of two factors, 8 and 9. Well, you're close because 9 is a perfect square root. But within the 8, you also have the square root of 4. So let's take a step back and see if there's another way to break this down. Well, another way to break down 72 is to do 2 and 36. So the square root of 2 and 36, 36 is a perfect square, so I have 6 square root 2. So that's how you would handle the 72. That is the most exact answer with the max amount of numbers coming out. Look at square root 68. Now this one seems a little more daunting, but actually it's a quite simple one. So the first thing we're going to do here is look at it and go, okay, what all possible factors can come out? Well, we know it's even, but that gives us 34, and 34 is also even, so we can take out more. So let's try a 4, because even, and then the breakdown is even again, that tells me at least a 4 can be taken out. So if we divide this by 4, we get 4 and 17. Well, this is actually a jackpot, because 17 is prime, so I can't break it down any further, but 4 is a perfect square root. So since I can break the 4 down, I am going to have square root 4 becomes a 2. Now radical 17 stays behind because we can't break it down any further. All right, folks, so this is the basics of just rationalizing a radical. In your future homework, you're going to have to do a little more work on this. So the second half of this is going to be rationalizing denominators with radicals. So let's say I have 5 over square root 2. First off, we need to understand some basic rules. You cannot have a radical in the denominator. It is considered incomplete. So to work on this, it's quite simple. You multiply the top and the bottom by the radical. Now, reasons behind this is very simple. We said when we squared a square root, it dropped the radical. Well, isn't squaring the square root the same as saying multiply it by itself? So square root 2 times square root 2, if I do it that way, becomes square root 4. Well, the square root of 4, we know, is going to become 2. So now my denominator is just 2. It dropped the radical. On the top, there's nothing we can do about that. 5 and square root 2 have nothing in common. We can't break it down. We just write them side by side because it's held by multiplication. And a number out front of a radical means that it is held by multiplication. Now, let's do another example. Let's say I have 9 over square root 3. Now, I chose this one in particular because a lot of times we jump to the conclusion that you can reduce that by cross-canceling, and we cannot, or reducing the fraction. It is a radical, which means it has a totally different amount than what you think it is. So we're going to treat it the same as what we did the one above. First off, I'm going to multiply top and bottom by square root 3 because we are trying to eliminate the radical on the bottom. So square root 3 times square root 3 is square root 9. The square root of 9 is 3. So that means my new denominator is a 3. The top is 9 square root 3. Now, here is where you can take and reduce this. So to reduce it, we're going to look at the numbers outside of the radical as an option. And in this case, it is a very good option. 3 goes into 9 3 times. So I am left with 3 square root 3 as my final answer. All right, so let's do one more. These are going to come into play more in your 9.2 and 9.3 assignment. So let's make sure we get a really good grasp on this. So this will come up in our 45, 45, 90 square root triangles and such. So when we get into this, what I want to talk about is the radical 2 as well. So you're noticing I'm using 2s and 3s, but it's because those are the 2 you're going to use the most on these assignments. So let's say I have 6 square root 3 divided by square root 2. Now, this is a little unique, but it is something that you can fall into. First thing off, you have to get rid of the bottom square root. That's always going to be a given. So I'm going to multiply the top and the bottom by square root 2. Once again, square root 2 times square root 2 is square root 4, which is going to give me a 2. So what I have now is 6 over 2. The radical actually multiplies. They are both square roots. Now this is very important. The only way you can combine these two is if the square roots are the same. So square root 2 times square root 3 is actually square root 6. Now, when we did our multiplication there, it still didn't give us a number that has to come out further. So we're not going to worry about that. What we are going to go ahead and do is reduce the fractions, or the numbers outside numerical coefficients. In this case, 2 goes into 6 3 times, so I'm left with 3 square root 6 as my final answer. All right, so I'm going to give you 2 problems to work on. You can pause the video and then check back with your answers. Here we go. Let's say I have 5 over square root 3. And let's say I have 2 radical 2 over radical 2. Yeah, a lot of 2's there, but I think you can handle it. So take a moment, pause the video, work these 2 problems. Okay, hopefully you've paused the video and this is what you've come out with. So just like the first two that we did, we have to rationalize the denominator by multiplying the same thing top and bottom, which is radical 3. So the two radicals here we know make square root 9, which becomes a 3. So on bottom we have the whole number 3, 5, and then the square root 3. In this case, nothing reduces, so you are left with 5 square root 3 over 3 as your answer. Remember, we're looking for exact answers. That's why we're not turning it to decimal. And you will notice your calculator does not help you with this. Keep in mind, we're asking you to work this out completely. All right, the last one that we're going to do down here, same thing, square root 2 over square root 2. We know this here is going to be square root 4, which becomes 2. So what I have here is 2 on the bottom, 2 up top, and then square root 2 times square root 2 is square root 4. Well, now we have an anomaly that happens here. So go ahead and drop out your 2's here. So those two are going to cancel out. The square root of 4 is just 2, so your answer comes out to be a whole number 2. There is other ways you could have handled how to finish this problem out, but at the end you will end up with square root 2. All right, well I hope this is enough to get you through your assignment as you go through. Remember, turning them to decimals is not going to help you get through the assignment. You have to keep them radicals. If you have more questions, I will post further videos. Good luck.